Welcome back, folks. Today we're tackling Objective 4, Coordinate Geometry. Now, throughout the course, pretty much for every topic or concept or shape we've dealt with, we've spent some time putting them in the coordinate system, on our XY axes. What we're going to do with this lesson is take all that coordinate geometry we've been dealing with all semester and combine it all into one lesson so we can just focus on what's going on in that coordinate plane. First thing we're going to talk about is finding the midpoint of a segment in the coordinate system. So if I have my XY axes and I have the segment AB, what we want to be able to do is find the midpoint, the middle of that segment, whether that line's going left, right, up, down, or diagonal, like we see in this case here. This visual kind of shows you how we're going to be calculating that midpoint. If we want to find the middle of this segment, basically we're just going to find the middle of the X direction and Y direction separately. And the way we'll do that is essentially take an average. So we'll say the coordinate in the coordinate plane, given points A, B at a general x1, y1, x2, y2. And those are any sets of x and y points. The coordinates of the midpoint are given by this, m equals x1 plus x2 over 2. In other words, the average of the two x values, comma, then for the y value, y1 plus y2 over 2, we're taking its average as well. Let's go ahead and use that formula here, show you how it works. Problem 1, finding midpoint. Part A says that EF has endpoints at E, 7, 5, and F at 2, negative 4. We want to know what are the coordinates of its midpoints. And for this one, I have a picture to kind of help us visualize what's happening, but we'd be able to do this problem without a picture. All we need are the numbers for the points. And again, we're using our midpoint formula. I'd recommend anytime you're using a more complicated formula, write that out the way it is on your paper in front of you. It's going to make it easier to fill in then. So we just said m's equal to the average of the x's. So we'll say x2 plus x1 over 2, comma, average of the y's, y2 plus y1 over 2. Then we can fill that in. So x2 plus x1. Now, as far as the actual points go, it doesn't matter which one we think of as the first one and which one we think of as the second one. Order really doesn't matter. So I'm going to pick an order here. I'm just going to go 2 plus 7 over 2. Then for the y's, I'm going to stay in the same order. Since I use the 2 as the first x coordinate, I have to use the negative 4 as the first y coordinate. So we can say negative 4 plus 5 over 2. So we fill our midpoint formula in with those 2 points, and then essentially we'll just evaluate, we'll reduce these 2 expressions down, and that's going to give us our x and y values. 2 plus 7 is 9, so we call this 9 halves. And negative 4 plus 5 is just a 1, so we could say 1 half. Or I suppose we'd reduce this down to decimal form. Half of 9 is 4.5. And a half, we could just say is 0.5. Either way, that's our midpoint. And again, what we're looking for is the direct middle of this segment we have. If I plot this point, if I go over 1, 2, 3, 4 and a half, and then up a half, oops, I'd say that makes sense. It looks like we found the correct midpoint. All right, so that's how you use your midpoint formula. Your note guide has a part B. Why don't you take a minute, pause that video, and then before you move on, throw a hand up in the air, get your answer checked, make sure you're good before we continue with the rest of the lesson. Next thing we're going to talk about is the distance formula. We want to be able to find the distance between 2 points in the coordinate system, or in other words, the length of a segment. And our coordinate system is great, nice and easy for counting distances left and right or up and down. But if we want to do something diagonally, just like with a midpoint, we're going to need a formula to do that. So set up in the same way here, we've got 2 points AB, And the distance between those points, A at x1, y1, and B at x2, y2, is going to be given by this kind of ugly mess here. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, where's that formula coming from? Well, this is just really the Pythagorean theorem rearranged, okay, because we're able to break down this distance into right triangles. Okay, we're not going to get into where that's coming from in this lesson. That's a different lesson. We'll just show you how to use it for now. All right, so problem 2, finding distance. Part A asks, what's the distance between U at -7, 5 and V at 4, -3? Okay, round to the answer to the nearest tenth. Okay, so for that, we're talking distance. We're going to use our distance formula. Again, I'm going to write that formula out on the page I'm working on here, okay, to make sure it's right in front of me when I go to fill it in. So we have the square root of x2 minus x1 squared, all right, plus y2 minus y1 squared. Okay, so filling things in, we've got the square root, and don't forget about that. Common mistake I'll see is students will do everything correctly, but they'll forget to do the square root when it's all said and done. So don't forget that. Now this formula just takes x minus x. So once again, the order doesn't matter. I'm just going to stay in the order the problem's given to me. We can say -7 minus 4. And that's all squared. Okay, plus then in the same order, okay, once you pick an order, you've got to stay in that order. In the same order, we'll go y minus y. So here we can go 5 minus -3. So 5 minus -3, in other words, plus 3 squared. All right, now technically we could plug this into the calculator the way we see it here, but I'm going to reduce it down just to make my expression a little less messy when I go to plug it in. So we've got the square root of -7 minus 4 is going to be a -11. So I'm going to say -11, and I'm going to put that all in parentheses to square it. Okay, that's going to help me remember when I square that negative number, I get a positive. Okay, if you want to do this on the calculator, you do need the parentheses there. Okay, plus 5 plus 3 is 8, so that'd be an 8 squared. And continuing, again, we could plug this into the calculator anytime we want, but I'm going to keep reducing it down. 11 squared is 121, so that means -11 squared is 121 as well. Okay, plus 8 squared is 64. If I add those two together, 121 plus 64 is going to be a 185. And then when I take the square root of 185, I'll go to my calculator at this point finally, I get a 13.6. All right, so that'd be the distance between these 2 points, U and V, in the coordinate system. All right, that's how the distance formula works. Once again, there's a part B in your note guide, so take a minute, pause the video, and then again, make sure that you throw a hand up, get your answer checked, make sure you're doing this stuff right before we move on and continue with the lesson. The next thing we're going to take a look at is writing equations of lines in the coordinate system. And really, this is where we're going to spend the rest of the lesson on, is kind of building towards writing equations. Now, in geometry, we spend a lot of time talking about lines, different types of lines, how they relate to each other, such as parallel, perpendicular lines. Okay, so we definitely want to be able to deal with those in our coordinate system, in our XY axes. Okay, we're going to start off with finding the slope of a line. We'll say the slope of a line is the ratio of the vertical change, the rise, to the horizontal change, the run. So basically, the slope of the line is how steep that line is. We'll say if a line contains the points x1, y1, and x2, y2, okay, 2 general points, then the slope m, okay, we'll abbreviate it as m, is, okay, the rise over run, which will be the difference in the y's, okay, the change in the y's, over the difference in the x's, change in the x's. Okay, so y2 minus y1 over x2 minus x1. All right, so let's go ahead and take a look at finding slope. Here we've got our coordinate system, our xy axes, and a whole bunch of different lines. Part A says find the slope of line A. Now it looks like line A is this line increasing from left to right, okay, as in blue here. And we just said that the slope is equal to y2 minus y1. So the change in y's, that's my rise, over x2 minus x1, change in the x's. And again, it doesn't matter what order we plug these points in. And for the slope formula, it also doesn't matter what points we use. Now I'm going to use the 2, 3 and the 5, 7 that are given to me here. But it looks like I could also use the -1, -1. Okay, I can really use any points on these lines. Okay, so y minus y, I'm going to say 3 minus 7. All right, over in the same order then, x minus x, so we can go 2 minus 5. All right, reducing that down, 3 minus 7 is going to be a -4. All right, over 2 minus 5 would be a -3. Okay, I can reduce that further because a negative divided by a negative is a positive, so I can just say this slope is 4/3. Okay, what does that mean? Again, that's the steepness of my line. And it basically describes how I get from one point to the next on my line. If I start at the 2/3 and I go with a rise of 4, 1, 2, 3, 4, and a run, so over 3, 1, 2, 3, I'm going to get to that next point. Okay, same thing if I start at any other point on this line, up 1, 2, 3, 4, right, 1, 2, 3. Okay, we can have a way to kind of generate all the points on this line. Let's go ahead and do part B together here as well. Okay, again, slope is y2 minus y1 over x2 minus x1. Okay, that'll be a formula we use a whole bunch before the lesson's all said and done today. Okay, B, that's this red line decreasing from left to right. We'll talk about kind of how that slope looks as we go here. Okay, so y2 minus y1, we'll go 2 minus -2. So we could say 2 plus 2. All right, over in the same order, x minus x, -1 minus 4. And for that, what I end up with is a +4 on top and a -5 on the bottom. What I'm going to do is I'm just going to put the 5 on the bottom and throw the negative out front. It doesn't matter if we think of the whole fraction as negative or just the top or just the bottom, it's still a negative slope. And we had a positive slope over in our first case. That means our line is going up from left to right. It's increasing. Okay, a negative slope is going to mean our line is decreasing from left to right. So if I go down 1, 2, 3, 4, okay, if I have a negative rise essentially, and over 1, 2, 3, 4, 5, we'll get to that next point. Okay, so positive slopes going up from left to right, negative slopes going down. All right, let's take a look at two more together in C and D. Okay, these are going to be our two special cases of slope. Okay, C, find the slope of line C. And notice line C here is horizontal. Okay, it's going straight left and right. It's never increasing or decreasing. Now, in general, anytime you see horizontal for a slope, you can just say that m is equal to 0. And the reason for that is if I calculate this slope here and do my y minus y, so in this case, that'd be a 7 minus 7, all right, over x minus x, 1 minus 5. Since the y coordinates are all the same on horizontal lines, we're always going to get a 0 on top. And I know 0 divided by anything, in this case a -4, is just equal to 0. Okay, so really no calculations necessary. Horizontal lines will just have 0 for a slope. Okay, D is another special case. Notice line D is vertical. It's going straight up and down. And anytime you see a vertical slope, we can just say that M, our slope, is undefined. Okay, undefined because it's essentially an infinite steepness. Okay, I can have as much rise as I want for no run. And again, calculation-wise, if I look at these 2 points, 4, 0, and 4, -2, and I go y minus y, so we could say 0 minus negative, so plus 2, all right, over 4 minus 4. Okay, the trick here is that since all my x coordinates on a vertical line will be the same, I'll always get a 0 on bottom. Okay, we've been saying since elementary school can't divide by 0, it doesn't work. Okay, so anything divided by 0 is just not a number. Okay, it's undefined. That's why we'd say we have an undefined slope there. All right, once we have our slope, our way of describing the steepness of a line, we can get into actually writing equations. And in geometry, we're going to look at 2 forms of equations of lines. Okay, there's more than that. You'll get to more later in future courses. Okay, but here we're going to talk about the slope-intercept form and the point-slope form of lines. Okay, the slope-intercept form of an equation of a non-vertical line is this guy, good old y equals mx plus b, okay, where m is the slope and b is the y-intercept. Okay, so in other words, y equals slope times x plus the y-intercept. All right, we're also going to use the point-slope form of an equation. Okay, and that is this, y minus y1 is equal to m times x minus x1, where again, m is the slope, and then the x1, y1 is a point on the line. Okay, any point on the line, we can plug into that equation. Okay, so for the next few problems, we're going to look at writing equations, graphing, using both of these forms of a line. And as we do that, we'll kind of discuss the advantages, disadvantages, and when to use each form of it. So let's go ahead and start graphing right off the bat. Problem A, we want to graph this y equals 2/3 x plus 1. And the first thing to do is recognize what type of an equation did they give us? Well, this is in y equals mx plus b format. This is in slope-intercept form. So when I'm graphing this equation is telling me 2 pieces of information. It's telling me the y-intercept, which is just a 1, and the slope, which is a 2/3. So what I'll do to graph this, guy, is I'll just put a point on the y-intercept. I'll go over to the y-axis. Okay, I'll find the 1, and I'll plot a point. Oops. And then to continue the line, what we'll do is we'll just follow a slope. Okay, it's 2/3, so from that point, we'll go up 2, so rise of 2, over 3. And then we can just continue that up 2, over 3. And the same idea in the other direction, we can go down 2, left 3, down 2, left 3. And put all those points on our graph. All right, that's graphing in our slope-intercept, our y equals mx plus b form. We'll give you a chance to practice that in a second here. I lied. Why don't you go ahead and practice that right now? Part B is graphing in slope-intercept form. Okay, take a minute, pause the video, run through that question, check your answer before we move on. All right, next thing we're going to do then is look at graphing a line in point-slope form. Again, that's our y minus y1 is equal to m times x minus x1 form. Again, just like slope-intercept form, this equation gives us 2 pieces of information. First thing it gives us is a point on the line. In this case, that's going to be -3, 3. Okay, the x value is going to be a -3, and I know it's negative because if I take x minus x1, and I end up with x plus 3, well, the only way to get that positive there would be to minus the negative. So my x value's got to be a -3. Same idea on the left side, it is y minus the y value of that point. So if I have y minus 3, I know that 3 is the y coordinate. Okay, trick here is that notice the sign switch as I go from point to equation or equation to point. Okay, pay attention to those positive negatives. There'll be a big mistake I see from students on a problem like this. Okay, so I have my point to start off with. And then I also know my slope. That's just this m here, this -2. So just like with slope-intercept form, I can start off by plotting this point at -3, +3. And then I can follow my slope. Now, when I say the slope's -2, I can think of that as a -2 over 1. Okay, rise of down 2, run of over 1. So I have my original point that will just go down 2, right 1 for the next one, down 2, right 1, down 2, right 1, down 2, right 1. And I suppose we can go to the opposite to fill out the rest of it, up 2, left 1. Okay, connect your dots. All right, there's my best line, and there's the equation of that line. Okay, there's also a part D. Okay, once again, why don't you take a minute, practice graphing in point slope form. So pause the video, and again, check your answer before you move on. Next thing we'll take a look at doing is writing equations. Okay, here it gives us the information, and we just want to fill that equation in for problem 5. Part A says, what's the equation of a line with slope 3 and y-intercept -5? Now here it doesn't specify what type of equation we want to write, so we can write any one we want. And I suppose we'll pick the easy one. Here it gave us a y-intercept, so I want to use my slope-intercept form, my good old y equals mx plus b. And for this one, all I need to do is fill in the m and the b. Okay, we have a slope of 3, so we can just say y equals 3x. And with a y-intercept of -5, so for the plus b, we'll just say -5. All right, b is the same idea. What's the equation of the line through -1, 5 with a slope of 2? Now this time, though, they didn't give us the y-intercept like they did in the part A, but they did give us one point on the line. If that's the case, we're not going to use slope-intercept, we'll use point-slope form. So that's our y minus y1 is equal to m times the quantity of x minus x1. Okay, so filling things in, we've got our slope once again of 2. And then we've got the x and y coordinates of one of the points on that line. So what I can do is say x minus the x coordinate, so minus -1, in other words, plus 1. And y minus the y coordinate, so we could say y minus 5 on the left side. Okay, again, it doesn't tell us what type of line we want, so we can pick any type we want. We can leave this in point slope form for now. All right, your note guides also have a part C and D. Okay, once again, take a minute, pause the video, work through those, and check your answers before you move on. All right, next thing we're going to do is basically put all the stuff from those last few problems together into a single question. And that's going to be writing the equation of a line through 2 points. Okay, part A says, what's an equation of a line at the right in slope-intercept form? Okay, and I really don't need the picture for this. I've got it to kind of help me visualize what's happening here, like we've done a few times today. Okay, the big thing I need is just these 2 points, 1, -4, and 2, -1. Okay, now anytime you're writing the equation for a line, start with the slope. Again, my slope is m equals y2 minus y1 over x2 minus x1. Okay, so y minus y, I can say -4 plus 1. All right, over same order, x minus x, we can say 1 minus 2. Okay, and that's going to give us a negative 3 over negative 1, which we could just call a positive 3 for a slope. Okay, then once I have my slope, I can start writing an equation. Now here, I'm not sure what my y-intercept is. Now the picture, I could kind of count to it, but let's pretend we don't have the picture. Let's just say I have these 2 points. So with this one, I can't start off with slope-intercept. I've got to start off with my point slope again. So I've got to go to my y minus y1 equals m times x minus x1 formula once again here. Okay, we'll fill in what we know. We know the slope. That was the 3 we found a second ago. Okay, then as far as which point to use for my filling in my equation, really doesn't matter. Okay, we can pick any point on the line. Okay, it doesn't even have to be the 2 we're given here. I'd say when you get to pick the one with the smaller numbers though. I'm going to use the 2, negative 1. So we can say x minus 2 on the right side, and then y minus the negative 1, so y plus the 1 on the left side. Okay, so there's the equation of my line in point slope form. Now, trick with this one is it says we want the answer in slope-intercept form. So what we need to do then is get our equation into y equals mx plus b form. And essentially all that's doing is it's solving it for y. If I can get y alone by itself on the left side, okay, we'll have the mx and the b on the right side. A first step for that is I'm going to distribute across my parentheses. Okay, so on the right, that would give me a 3x, and then 3 times negative 2 would be minus 6. On the left, we've still got the y plus 1. And then last step to get the y by itself, I'm just going to subtract 1 on both sides. That'll leave me with just y on the left is equal to 3x minus 7 on the right. All right, there's my answer in slope-intercept form. Okay, so that's how to write the equation of a line through 2 points. Okay, pretty common question, something you want to be able to do just because it combines all the stuff that we've been talking about with lines in the coordinate system so far. Okay, there's a part B as well. Once again, take a minute, pause the video, work through that one, and then check your answer before we move on. All right, we've got a few more things we're going to do with this lesson today. Okay, a few more things dealing with lines in the coordinate system. Okay, problem 7 is going to deal with writing equations of horizontal and vertical lines. Okay, part A says, what are the equations of the horizontal and vertical lines through the point 2, 4? Okay, now I don't need a picture to do this problem, but it's going to be kind of helpful to have one just to explain things. So if I make a general, sloppy XY axis, and let's just say the point 2, 4 is somewhere around here. Okay, I'm not going to actually make tick marks and count things off. We'll just kind of estimate where it's going to be. Okay, a horizontal line is going to be a line running straight left and right through that point. Okay, the way I can describe that is I can use where it intercepts the y-axis. Now it's going to hit the y-axis at the same y-coordinate of that point, just a 4. Can I know the y value of my any point on this line is going to be 4. That's why I can describe this equation as y equals just a 4. Okay, as far as y equals mx plus b, again, we said that horizontal lines have 0 for a slope. So if it's a 0x, we're left with just the y-intercept, we're left with just that 4. Okay, we can kind of sort of do the same thing for vertical lines. Okay, a vertical line is going to be a line running straight up and down, okay, through our point. Let me try to draw. I was gonna say I'd draw a straighter line, but yeah. All right. In a similar manner, we can look at where that line intersects the x-axis. Okay, well, it's going to intersect it at the x-coordinate of this point, at the 2. If this line is vertical, every point on it is going to have an x-coordinate 2. That's why I can describe it as just x equals 2. Okay, so y equals equations for horizontal lines, x equals equations for vertical lines. Now, the big trick is going to be making sure you don't confuse the two. Okay, so that's why I'd recommend draw the quick picture just to make sure you're keeping things straight in your head. All right, once again, with part B, pause the video, take a minute, work through this one, and then check your answer before you move on. All right, and the last set of concepts we're going to talk about are slopes of parallel and perpendicular lines. We'll start off with parallel in this example. We're going to say parallel lines have equal slopes. So if I have two parallel lines here, two lines that are not going to intersect, basically for them to not intersect each other, they have to have the same rise over run. Okay, that way if they're kind of following that same pattern, these two lines will never catch each other and run into each other. Okay, so in problem 8, we're asking the question, are the lines shown in the graph parallel? Well, so basically what we're asking there is, do they have the same slopes? Okay, so if we call our first line on the left here L1, we can calculate its slope. Okay, so doing slope formula for the who knows how many times a day now. Y minus y, we can say -5 minus 3. Okay, over in the same order, x minus x, we'll go -3 minus 1. That's going to reduce down to a -8 over -4, which would be a +2. Then we can do the same thing for the other line. We'll call that L2. So we're talking about M1 for slope 1. We can look at then M2 for the second slope. Same thing, y minus y, we can say 2 minus the -4. I'm sorry, 4 minus the -2, or 4 plus 2, I did that backwards. Okay, over in the same order, 5 minus 2. That's going to give me a 6 over 3, which will also reduce down to a 2, or a 2 over 1. So back to the question, since these lines have the same slope, I know they are parallel. So to answer this one, we'd say yes, we are looking at parallel lines here. All right, next up, we'll talk about the slopes of perpendicular lines. We'll say perpendicular lines have opposite reciprocal slopes. Okay, as in if one slope is A over B, the other one would be the opposite, so negative, and reciprocal, flip the fraction upside down, B over A. Okay, so let's go ahead and check the slopes of these lines. We'll say my line with a negative slope, the one decreasing from left to right, is my L1 here. So are the lines shown in the graph perpendicular? That's what we're checking. Okay, we want to check, do they have opposite reciprocal slopes? So we'll say M1 is equal to y minus y. So we can say 5 plus 4 over x minus x, so -2 minus 1. So we get a 9 on top over -3 on bottom, which would be a -3 for a slope. Okay, and then the same thing with our L2. We'll look at slope 2. Y minus y will be 4. Whoops, sorry, I'm getting ahead of myself. 1 minus 4. All right, over -4 minus 2. And that's going to give me a -3 on top over a -6 on the bottom. Okay, which reduces down to a 1/2. Okay, in this case, I'd say no, these two slopes are not opposite reciprocals. The opposite reciprocal of 1/3 would, or of -3 would be positive 1/3. Okay, if I take the -3/1, change the sign, flip it upside down. And the opposite reciprocal of 1/2 would be a -2/1. Okay, these are not opposite reciprocals, so that's how we know that these slopes are not perpendicular. All right, then last thing we're going to look at doing is writing the equations of parallel and perpendicular lines. Problem A says, what's the equation of a line perpendicular to y equals 1/5 x plus 2 that contains the point 15, -4? Right answer in slope-intercept form. Okay, now I'm going to say that we've already done a problem just like this. The only difference is when we say we want something parallel or perpendicular to another line, that's just another way of giving you what the slope's going to be. Okay, so if I want an equation that's perpendicular to this y equals 1/5 x, my slope then is going to be the opposite reciprocal of 1/5. In other words, -5/1. Okay, so once we have our slope, we can go ahead and write our equation out. Now here they gave us a point, so we'll go to point slope form. We'll fill in what we know. We want to be perpendicular to the line given with this slope of -5/1, or we can just say -5. And then filling in the x and y values, we'll say x minus the x, so -15. And then on the right side, y minus y, so minus -4, we're going to say +4. Okay, so there's an equation of a line perpendicular to the given line through this point. Now, last thing, once again, we want our equation in slope-intercept form. Okay, get it down to our nice y equals mx plus b form. So let's go ahead and run through that one more time. We want to solve this equation for y, so we can distribute the -5 on the right. That's going to give us a -5x. All right, -5 times -15 would be +75. We still have the y +4 on the left. And the last step, we'll subtract 4 on both sides. And that'll give us y equals a -5x plus 71. All right, problem B is the same idea. I believe problem B, though, has a parallel line. So that'd be same slope as opposed to opposite reciprocal slope. Pay attention to which type of line we're looking for. But once again, take a minute, run through that one. And before we move on to the homework, the Math Excel, make sure you do check your answer. Make sure you're doing this stuff right before we move on from the lesson.